Hey everyone, welcome to Div Trends on the Go. Today's Qiita picks. It is July 16th, 2026. This show is totally perfectly paced for your morning commute, just to get you caught up on the tech world.
Yeah, and for our global listeners who might be tuning in, Qiita is basically the beating heart of the Japanese developer community. I mean, think of it as their version of dev.to or Medium. It's where, the really practical everyday engineering knowledge gets shared.
Exactly. And before we get into the top articles, if you could just do a really quick favor and hit that subscribe button, maybe leave a like on whatever app you're using. It takes like 2 seconds and it really helps us out.
It definitely does. So, starting off today, there's a trending analysis on Qiita about an Anthropic blog post. It covers their new Claude Fable model.
Oh, nice.
Yeah, and the author makes this really interesting argument. They say that AI output quality isn't actually bottlenecked by the model itself right now. It's actually bottlenecked by our own inability to verbalize our unknowns.
Wait, isn't the whole point of using AI that it, figures things out for me? Like if I have to map out every single variable, I might as well just write the code myself.
Right, that's exactly the trap we all fall into. We assume the AI has context that it just doesn't have. So the article breaks this down into 4 types of unknowns.
Okay, I'm listening.
The first one is super straightforward. Known knowns. You know you need a function to parse a CSV, you ask for it, it writes it, it works.
Easy enough.
But the second category is where it gets interesting, which is known unknowns.
So you mean like knowing I need a database connection, but I don't know which ORM I'm going to use yet, so I explicitly tell the AI, just leave the ORM blank for now.
Yes, exactly.
Right.
You're actively pointing out the hole in your own architecture, so the model doesn't just confidently guess and build something you have to rip out later.
That makes sense.
Then you have the third category, which is tricky, unknown knowns. These are basically your unverbalized preferences.
Oh, like when it builds a UI using standard CSS, and I get totally annoyed because I'm like a massive Tailwind person.
But you never actually told it to use Tailwind.
Exactly, yeah.
We judge the output against these constraints we just kept hidden in our own heads.
Yeah, I do that constantly.
We all do. But the final category is the one that actually breaks production, which is unknown unknowns. You just don't even know what the problem space is. Like, you ask for a scalable database schema, but you're completely unaware that your specific read-write ratio means you actually need a specialized caching layer.
But if I don't even know what I'm missing, how can I prompt for it? The AI doesn't have telepathy.
Well, the author says that expert, sort of agentic coders, they assume these blind spots exist. They actively work to minimize them before they even start prompting for code.
Oh, so they asked the AI to find the blind spots first.
Right. Being a good AI prompter means you're basically a master of defining what you don't know.
That is super useful for any developer who, feels stuck just getting really mediocre generic code from these assistants.
Exactly, yeah.
Oh, that sounds a lot like another piece I saw trending, actually, about using Claude Code as a mentor instead of just a code generator.
Yeah, that's a great connection. So this article provides 5 very specific prompts to turn Claude Code into a teacher. Things like beginner tutor, error resolution, active engineer thinking, review and improve, and learning roadmap.
And the big difference here is that Claude Code runs locally, right?
Yeah, it runs right in your terminal. So it
Mhm.
actually reads your local files, your directory structure, your real stack traces.
So that means it's exactly like having a senior developer sitting at your desk, just looking over your shoulder at your actual screen.
That is the perfect way to look at it. And the author really emphasizes that active engineer thinking mode. So instead of just pasting an error and saying, fix this, you ask the AI why it designed a solution a certain way.
Like asking about the trade-offs.
Exactly. You ask about trade-offs, maintainability, things like that, rather than just copy-pasting code and hoping it works.
Which is huge because I'm definitely guilty of the whole search, get confused, copy a snippet, and give up loop. But combining these prompts creates more of a continuous learning loop.
Right. You're learning the why, not just the how.
That is incredibly useful for junior developers, or honestly, anyone picking up a brand new framework.
Go for it.
The next one is interesting because it takes that same idea of AI agents, but scales it up in a massive way for research.
Oh, yeah, the multi-agent experiment. This was fascinating. A developer built a system using 100 AI agents running in parallel.
100? Wow.
Yeah, and they were investigating YouTube customer acquisition techniques.
Okay, wait, how would you actually use this at work? Just have 100 bots Googling things.
Well, it's more structured than that. The article focuses heavily on the verification step. The system pulled 25 verifiable claims about YouTube marketing. And then 75 of those agents engaged in what's called adversarial verification.
Adversarial verification. So just setting up AI bots to argue against a claim to see if it actually holds up to scrutiny.
Yep, that's exactly what it means. They try to attack and debunk the claims by finding contradictory evidence or checking to see if it's just marketing hype.
That sounds intense. How long did it take?
It took about 144 minutes and burned through 2.3 million tokens.
Oh, wow. That is a hefty API bill. Did any of the claims survive that?
Out of the 25, only 5 survived. More than 8 were completely rejected.
That's crazy. But honestly, it proves that AI can handle really complex, multi-agent, critical thinking tasks, not just, generating blog posts.
Exactly. It's moving from text generation to actual logic and verification.
Which is super useful for marketers, researchers, or even developers who want to build automated fact-checking pipelines.
Yeah, absolutely.
Quick question before we move on, though. If we're using AI to process all these massive amounts of data and tokens, how do we actually store and search all that information efficiently?
Well, that segues perfectly into an article from some AWS and Oracle engineers. It tackles this huge misconception right now that if you use an AI database, you should just dump all your application logs into a vector store for RGAC.
Wait, really? I thought vector databases were like the gold standard for AI right now.
They are, for certain things. But vector embeddings are designed to measure semantic meaning, not chronological order or hard counts. So if you put time series data, like logs, into a vector store, it falls apart.
Oh, because the time 4.00 p.m. and 4.01 p.m. basically mean the same thing semantically, but logically they're completely different events.
Exactly. The AI struggles to just count rows. So the article outlines a proper architecture, which they call an autonomous AI lakehouse.
Okay, so what's the setup?
You keep your massive structured time series data in a standard SQL database. You only use vector search for unstructured text that actually requires semantic understanding.
Like error messages or huge stack traces.
Right, or JIRA comments. And then you use RAG, which just means letting the AI read reference material before it answers. You use that to explain the SQL result in natural language. You don't use it to do the heavy lifting of the search itself.
So you mean like keep the spreadsheets for the hard numbers and only use the AI for the messy text?
Exactly. Don't make RA the main character of your entire data search pipeline. A hybrid architecture with SQL and vector search is way more realistic.
And definitely more cost-effective. This is vital for cloud architects and data engineers trying to manage AI costs at scale, for sure.
Absolutely.
So we've talked a lot about the back end and AI. Let's bring this all the way from the cloud down to the front-end UI.
Yeah, let's talk Vue 3. There was a great post from a front-end developer sharing their sort of stumbling block notes on Vue 3's reactivity.
Oh man, reactivity in Vue 3. I always get tangled up deciding when to use ref versus when to use reactive.
It is super common. But this article gives a fantastic visual rule of thumb. They say, use ref for a single small element.
Like a single status bar or a toggle switch.
Right. And you use reactive for an entire screen or a clustered group of data. Like, think of a whole character creation sheet in a game, or a massive multi-input registration form.
Okay, so in video game terms, ref is like holding a single health potion in your hand, but reactive is your entire backpack inventory.
That is spot on. And the cool thing is, for forms, reactive is perfect because Vue's vModel can link all the different form inputs directly to that one grouped state object.
Ah, so you don't have a million different variables floating around.
Exactly. It's a mental model shift.
Yeah.
You go from thinking about variables to thinking about data as it's actually tracked by the UI.
That makes so much sense. That is highly useful for any front-end developer transitioning to Vue 3, or honestly, just anyone struggling with state management design.
Yeah, it really simplifies things.
Well, I think that is all the time we have for today's top articles. Thank you all for listening. Don't forget to subscribe and like the podcast on whatever platform you use.
And definitely tune in tomorrow because we have a new episode of Dev Trends on the Go every single day.
Have a great day and happy coding.
Farewell. And hey, as you're working today, maybe ask yourself, what unknown unknowns are hiding in your next AI prompt?